5.5 Part 2, Example 3 says to find all solutions in the interval from 0 up to 2 pi of this equation here. So first thing notice is this has a sine and a cosine in it. So we've got to find some way to make them both sines or make them both cosines. And so there's different routes you can go, but they also have different angles, so it's going to make it a little trickier too. So different things you can do, but I'm going to show you what I thought of. So I remembered that sine and cosine are co-functions of each other. So I could possibly get this to be where cosine of 2x will be equal to cosine of something. And then I can use that one-to-one function that we learned back in when we did logarithms and when we had talked about exponents, things like that. So I'm going to, first thing then is I'm going to set these equal to each other. So I'm going to move this sine over to the other side. So cosine of 2x equals negative sine of x plus pi over 4. Now, I know that sine and cosine are cofunctions, but that sine is a negative in front of it. So I can get rid of that, excuse me, because I know that sine is an odd function. And remember, there was that rule that said if you had sine of a negative angle, that's equal to negative sine of the positive angle. So we can go backwards. So instead of the negative being out here, we could put the negative inside because it is odd. So I can rewrite this as sine of negative of that angle. And so I just got cosine of 2x equals that. And now I'm just going to simplify that right-hand side. So I'm going to distribute the negative. So sine of negative x minus pi over 4. Now, how do we get from sine, though, to cosine? So remember, this is sine of an angle. So this is our theta, okay? So there's a rule that says that sine of theta is equal to cosine of pi over 2 minus theta. All right? So sine of our theta here is the same as saying it's equal to cosine of pi over 2 minus theta. But what do we have instead of theta? We have a negative x minus pi over 4 there. This other side's still not changing. So now all I'm going to do is simplify that right-hand side now. So I'm going to distribute the negative. So I got cosine of pi over 2 plus x plus pi over 4. And then I'm going to combine those like terms right there. And so when I do that, that's going to give me cosine of x plus 3 pi over 4. Alright, so now that we got this one-to-one function, we can basically kind of remember if the trig functions are the same, we can get rid of them and we can set the two things equal. But you got to think about quadrants still, okay? 2x is equal to a positive x plus 3 pi over 4, okay? So where is cosine positive? It's going to be positive in quadrants 1 and 4. So let's talk about that. So in quadrant 1, our angle, that 2x, then will just equal the x plus 3 pi over 4. And because we're doing multiple angles, I still need that plus 2 pi in. But be careful. When we go to do quadrant 4, it gets a little bit trickier, okay? So we're going to have our 2x equals. But now remember, it's got to have the same reference angle as the one that's in quadrant 1. So let me draw that real quick here, okay? So I don't know where the angle is, but let's just say it's this one, okay? So this is going to be my theta. So remember, to be in quadrant 4, it's going to have that same reference angle there, okay? They're going to be equal. So how would I find that angle? Remember, when you're looking for a quadrant 4 angle, you subtract it from 2 pi. So we're going to have 2x here for quadrant 4 is equal to 2 pi minus our angle. What was our angle? X plus 3 pi over 4 And then because we're doing multiple angles, we still have to put plus 2 pi in. Alright, so let's work on that quadrant 1 angle. We've got to get the x, you got to solve for x, so let's subtract this x here. And so we get x equals 3 pi over 4 plus 2 pi n. Now for this quadrant 4 one, we're going to do a little bit more work. So first thing is I'm going to distribute the negative. So 2x equals 2 pi minus x minus 3 pi over 4 plus 2 pi n. Alright. I'm going to do two things here. I'm going to move this x over, and then I'm going to combine these two that are like terms. So when I do that, I've got 3x equals 2 pi minus 3 pi over 4. Remember, 2 pi is the same as 8 pi over 4 minus 3 pi over 4 is 5 pi over 4. And then we got our plus 2 pi n. But we're not done yet. We haven't solved for x, so we're going to have to divide everything here by 3. So this gives us x equals, remember dividing by 3 is the same as multiplying by 1/3. So we get 5 pi over 12 plus 2 pi n over 3. Alright, so we still just want it between 0 and 2 pi, so now we're going to have to make our table here so we can find out which ones work for us. So we're going to pick an n value. We have 3 pi over 4 plus 2 pi n. I'm going to skip a little space here. And then I got the 5 pi over 12 plus 2 pi n over 3. Alright, so let's plug in negative 1. So it gives us 3 pi over 4 minus 2 pi. Which if we're subtracting 2 pi, obviously it's going to be negative, right? So it's not going to be between 0 and 2 pi, but for those that want to know, it is negative 5 pi over 4, which is too small. So I'm just going to go ahead and do the same one here. So I'm going to plug in 0. So 3 pi over 4 plus 2 pi times 0 is 0. So we just get 3 pi over 4, which is between 0 and 2 pi. I'm going to plug in 1. So 3 pi over 4 plus 2 pi times 1 is 2 pi. When you do that, you get 11 pi over 4, which is too big. So therefore, we only got one answer out of that group. So now let's try the next one. So 5 pi over 12 plus 2 pi n over 3. So we got 5 pi over 12. Let's plug in negative 1. So it's going to make it minus 2 pi over 3. Now, 2 pi over 3 is the same as 8 pi over 12. So it's going to give me a negative 3 pi over 12, which is a negative pi over 4. But either way, it's negative, so we know it's not between 0 and 2 pi. So we plug in 1 for n. Oh, I'm sorry, let's plug in 0 first. So we get 5 pi over 12 plus 2 pi times 0 over 3 is 0, which is 5 pi over 12, which is between 0 and 2 pi. And then let's plug in 1. So 5 pi over 12 plus 2 pi times 1 over 3 is just 2 pi over 3. Remember, 2 pi over 3 is the same as 8 pi over 12, which gives us, what, 13 pi over 12? So that one works. That's a little bit more than pi. So I'm going to have to try another one. Let's try 2. So we got 5 pi over 12 plus 2 pi times 2 over 3 is 4 pi over 3. 4 pi over 3 is 16 pi over 12. So 5 pi over 12 plus 16 pi over 12 is 21 pi over 12. Now remember, 2 pi will be 24 pi over 12. So this one still works. So I got to try one more, and I'm out of room, so I'm just going to have to do it over here. So I'm going to make another little column here. So I'm going to try 3, and I'm only going to try that one right there. So we got 5 pi over 12 plus 2 pi times 3 is 6 pi over 3, which is just 2 pi. And obviously I'm adding 2 pi to some other positive number, so it's going to be larger than 2 pi. But when I do this, I should get 29 pi over 12, which is too big. And so we can see there what our answers are. So to group them, though, we get x equals, let's see, we had 3 pi over 4, 5 pi over 12, 13 pi over 12, and that 21 pi over 12, I didn't catch it, but just looking at that number there, all of a sudden, I realized it reduces. They're both divisible by 3, so this is the same as 7 pi over 4. So you need to make sure you reduce it if it's possible. And I almost missed that. All right, so there is our solutions for this problem.